Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 37 and we were discussing the unit number 7 and that was pressure. We discussed the very basic concept of pressure. And I told you that pressure is force per unit area. The SI unit of pressure is Newton per meter square or Pascal. Mathematically, we denoted P is equal to F divided by A. Ladies and gentlemen, to clear this concept and apply this pressure concept in our daily lives, let us do a work example which is given on page number 98 of your book. In the last lecture, I given you the concept of stiletto and the flat sole a lady is wearing. And we said that stiletto is exerting more pressure on the ground than flat sole shoes. Let us elaborate it with an example and then we will derive a conclusion. Work example 7.1 is saying calculate the pressure under a girl's feet if her mass is 50 kilogram. Here M is given to us as 50 kilogram. Uh, and the area of her shoes is in contact with the ground is in part number A, area in the contact with the ground is 20 centimeter square. 20 centimeter square, and that is for stiletto. We are going to find the pressure exerted by the stiletto on the ground. So we know that P is equal to F divided by A, but F is not given. For F, we are given other type of data. M is there, yes, and G is universal constant. Uh, uh, so M is equal to 50 and I am writing 10 instead of 9.8 for simplicity. So it means that 500 Newton they are exerting a force on the ground. Now P is equal to 500 divided by area is given to be 2. So when we cut this 500 is the F, M is 50 and G is 10 kilogram. It is written in advance for you people take acceleration due to gravity. G is equal to meter per second square. So they given us is 500. So when we multiply this 500 and that is given in the centimeter, so 10 2 into 10 raised to the power minus 4 will be the area here. If we are writing 2.0 into 10 raised to the power 2, and because meter is centimeter square is there, so when we are taking the square, so it will become -4. Now, ladies and gentlemen, when this is the situation, then we are getting the final answer is equal to uh, 2.50 into 10 raised to the power 6 Pascal. P is equal to 2.50 into 10 raised to the power 6 Pascal. And ladies and gentlemen, you know that Pascal is the unit of the pressure, so we are writing. Keep this in mind. At the end, we will conclude a very important uh, result from it. In the second case, they are saying that the area in contact is 200 centimeter square. In this case, this is 300 centimeter square. Now we have to convert this also to uh, 200 centimeter square means 200 into 10 raised to the power -4 meter square. Uh, for that also weight is given as F is equal to, this was area, and again force is 500 Newton as we calculated in the first part. So now in this case, pressure is equal to 500 divide by 200 into 200 into 10 raised to the power 200 into 10 raised to the power -4 Pascal. Ladies and gentlemen, when we calculate this, we are getting, it is already calculated 2.50 into 10 raised to the power 5. 2.50 into 10 raised to the power 5 Pascal. Now, when the area in contact is 20 centimeters square, a pressure of 2.50 into 10 raised to the power 6 Pascal is exerted on the ground. When that area in contact with 200 more than the first case, centimeter square, then we are getting the pressure is 2.5 into 10 raised to the power 5. Less area in contact, more pressure. More area in contact, less pressure. This is the confirmation of our yesterday's theoretical portion that if a lady is wearing stiletto, then it means that she will exert a very small force on the uh, ground. But if she is wearing a flat sole shoes, she will exert less pressure. And this is our conclusion as well. Ladies and gentlemen, let us now turn our focus to the second part, and that is called atmospheric pressure. Ladies and gentlemen, before explaining the concept of atmospheric pressure, let us do two experiments then we will pave our way to the atmospheric pressure. Ladies and gentlemen, uh, some water is heated to boiling in an open can, and it is closed by screwing on its cape tightly. Yes, it is written in your book. There is a cane, and if that cane is heated, and then suddenly we cooled it down by running cold water on its surface, we will see that the cane is crumbled. Why it is like this, ladies and gentlemen? Now, in the second example, if there is a air sucker, we are mostly using in plumbing, and if we press the two suction pumps inwards to get the air out of it, you will feel extreme difficulties to separate these two pumps. Again, what is the cause of this? Ladies and gentlemen, there is a conclusion from this that atmospheric pressure is present in outside of those two suction pumps and etc. We can conclude that there is energetic molecules present in the air which is doing bombardment of the over the surface of that two suction pumps or outside of that can. There is pressure inside the can as well. When we heat the water inside that can, so it means the molecules are getting much energy, and they are exerting greater force on the walls of the container and pushing it outwards. There is an atmospheric pressure from outside which is cancelling the effect of each other, and as a result the cane is not crumbling. But when we pour cold water on the surface of cane, the molecules inside the cane become cooled, losing its energy. So internal energy will be less and external energy will be more. So it will crumble. Similarly, when we press the two suction pump together, then it is producing partial vacuum inside, and from outside there is a pressure on the rubbers of those suction pumps. So if we are trying to separate these two from each other, it will be very difficult. uh, we can say that there is atmospheric pressure available on the air at the sea level, that atmospheric pressure is 1.013 into 10 raised to the power 5 Pascal, and this pressure is sometimes known as atmospheric pressure. At the sea level, the atmospheric pressure is 1 ATP, atmospheric pressure. Ladies and gentlemen, when we are going away from the sea level, either moving upwards or downwards, then this atmospheric pressure can be increased or reduced. Ladies and gentlemen, we will discuss that scenario as well. But what is one atmospheric pressure? Let us first elaborate it. If you are putting 1 kilogram of weight, which is equal to 10 Newton on 1 centimeter cube, on 1 centimeter square area, 1 centimeter square area, then the force is said to be 1 Pascal. 1 kilogram on 1 centimeter square area, then the pressure exerted is 1 atmospheric pressure. And at the sea level, this is called 1 atmospheric pressure. Ladies and gentlemen, when miners are going deep down many kilometers in mines, then they are feeling difficulties in breathing. Why it is so? Because their internal atmospheric pressure is, and from outside the atmospheric pressure will be more than 1. So the miner will feel difficulty to expand the sac inside the lungs, because outer pressure is more and internal pressure is less. So your body will be pressed firmly and it will not allow you to expand the sacs. So you will feel difficulty. Similarly, climbers to the mountains, when they are climbing far away from the sea level, then the pressure there is decreasing, while internal pressure is still 1 atmospheric pressure. And at high altitudes, the pressure is less, means less oxygen, so you will feel difficulty and breathing. So atmospheric pressure is playing a very vital role in different phenomena. Let us discuss using atmospheric pressure. Using atmospheric pressure. Ladies and gentlemen, one phenomena is that if somebody is taking juice through a straw, there is external pressure on the surface of the liquid. When you are taking the breath, so it means the sacs inside the lungs are expanding. It will reduce the pressure inside that. And in the mouth And in the lungs, when you are expanding your lungs, it will reduce pressure inside the lungs. But there is a constant atmospheric pressure on the surface of the liquid from outside. It will push this to that less atmospheric pressure area to mouth. So in this way you can suck this liquid from the container into the mouth very easily. When there is a gap inside the mouth and lungs, it means pressure will be less because area is more. When there is a constant pressure, the atmospheric pressure is more, and the pressure inside the mouth and lungs is less. So from high pressure it will go to the low pressure, and as a result we will be able to drink these juices. So this is one example of providing atmospheric pressure. Now the second example is there is a syringe in which there is a needle, and drag we want to drag this liquid from the container into this cylinder, which is connected with a spindle. When we are dragging this spindle upward, so it means that area will be increased, which will reduce the pressure inside, but there will be a greater pressure on the surface of this liquid. So this liquid will automatically be pushed upward to the cylinder of the syringe. If there was no atmospheric pressure in these two cases, we won't be able to uh, move these liquids to the straw or to the syringe. So here atmospheric pressure is again playing a very important role. So do not underestimate the atmospheric pressure. Now we are giving you the third example, and in the third example we are using the rubber hanger in which we are hanging clothes at homes. And might be you have seen on the windscreen of the car that they are hanging some chains, etc. there. So there is a rubber sticker which is playing the role of a hanger. And we are also using the hangers at our homes to hang clothes, etc. inside it. Ladies and gentlemen, when we are pressing this inward, so it means that partial vacuum will be created inside that. The external pressure will be more and the internal pressure will be less. When the internal pressure is less and external pressure is more, so it will stick, this rubber will stick firmly to the wall, and we can then hang any type of clothes or whatever we want without the disturbance of that hanger. Ladies and gentlemen, these three were the very famous examples of atmospheric pressure playing role in our daily lives. There is another topic which is called pressure in the liquids, but that is a very big topic. So I am leaving it here because we will not be able to complete that at in time. So thank you very much for watching. Tomorrow we will discuss pressure in liquids, which is also a very important topic. So take care. Allah Hafiz.